Hello and welcome everyone for another Mountz webinar. Today we are going to talk about automation in the assembly processes and how this can help you elevate your assembly lines. But before we jump in on the subject, and for those who don't know us yet, let me give you some background on who we are. Mountz is a family-owned company that was created in 1965. And since then, we've developed internationally. So our headquarters remain in Northern California with our main distribution and warehouse facility in Alabama. And we now have our international sales and service center just outside of London in the UK. Historically, Mountz has always been focusing on torque. And as such, we've been offering to the market torque measurement devices and tools to apply torque. And in the early 70s, we were the first company to create and provide the first electronic torque analyzer for a very famous defense company. Our customers operate in very different fields: medical, defense, aerospace, and electronics being among the most popular. As of myself, I'm Adrien Auger, technical sales manager with the international team, and I have traveled to many different places around my 10 years of experience in the assembly business. So this gave me the possibility to meet with several customers and have to face several types of application, which brings me quite some experience on how to answer your questions and how to help you reach your requirements. So today, as of with every webinar, we will be able to answer your questions at the end. So if you have any questions throughout the presentation, feel free to write them in the chat and we'll be happy to address them at the end. So jumping back to the subject, smart assembly automation. It's a very simple concept in the end, which aims to have a controlled process reaching a consistent quality through high precision and repeatability. So this entails various different subjects, and the first one is going to be error proofing. Today, more and more smart assembly tools are available, and one of the key features that they bring to the market is this error proofing. Most smart assembly tools will have different fastening strategies, and the most popular one is going to be TCAM, which stands for Torque Control Angle Monitoring. And in this case, we have a target torque with an angle window, and the other type of strategy commonly used is going to be angle control torque monitoring, so with a target angle and a torque window, which is called ACTM. So the aim of these error proofing features is to ensure that the tool will detect if anything goes wrong during the rundown, so that if there is a cross thread, as an example, the tool will detect it. If the part or the fastener runs for too long, the tool will detect it, so that we can really spot the issue right when it happens and take the corrective actions. So this is the first idea of error proofing, but there is also an additional layer, which is screw counting, which is also available in most of the smart tools. And so the screw counting mixed with these error proofing features of angle window or torque window is going to help ensure that not only the fasteners have been properly tightened, but that each fastener is present on the part before it leaves the workstation. So of course, for you as a user, it's important that this information is centralized and that the tool communicates with the different items and tools in its environment so that you can have a smart assembly line. And this really brings us to the real-time data and monitoring. So when we talk about data, there are two keywords that are really relevant in the industry today. The first one being monitoring, and the second one being traceability. So monitoring is the fact that the tool is monitoring and checking in real time everything happening on the fasteners so that the operators have a real-time feedback from the tool, ensuring that everything runs smoothly or ensuring that any error is again detected in real time. And most of the smart tools will also give out this data in real time through different communication ports, RS-232 Ethernet ports being among the most commonly used, so that you can also connect those tools to your networks and receive and store this data on your own devices. Which then brings us to traceability. And again, the traceability aspect is the fact that we can go back in time to check what happened on a specific part. And this is really related directly to the fastening data. So fastening data will generally imply to have the fastening date and time, the fastening strategy that was used, the target torque, the torque that was converted, so really applied on the fastener. Generally speaking, we will also have a barcode information so that you can track this data back to a specific part or to a specific lot, and also an error code to help you identify which type of error happened, if any, so that you can then take the corrective actions and use this data to help you improve your production line. Here, data is going to be important also for different aspects and different quality purposes. The first one is going to be internal, so that we can have then the documentation that the quality department is looking for. We can also comply with our internal audits, but more and more, it's also helpful for external actors. The first one being ISO certification auditors, so that you can show the documentations to these auditors, so that you can then receive the accreditation for the ISO standards you are looking for. Another aspect that is also being more and more applied is for your own customers, so that those customers can come and audit your assembly line, so that you can then show them that your assembly line meets with their requirements and that will bring them peace of mind, so that when they receive parts from you, they know that those parts have been properly assembled and the tools are properly tracked as well. Of course, the aim of all this control is to have a smoother and leaner assembly line. And if you want some more in-depth view of a linear assembly station, I invite you to go back to our previous webinars, where we really go into details into what is a lean production environment. So here, in a nutshell, the aim is to have a workstation that is repeatable and accurate so that the operators run the workstation the same way, whichever part is being assembled, so that in the end, you know that two similar parts from two different lots will have been assembled exactly the same way with all the data that is available to them. In the end, automating your assembly line and your workstations is going to help you reduce your running cost. First, of course, it's a matter of quality. As you improve the quality of the tool and the quality of the control you have on your assembly process, you reduce the cost of non-quality achievements. And these are simply the fact that you detect if an error happens, so you can take the corrective actions right away, meaning that you can either remove the part from the line and rework it later on, or you can rework it right away directly on the workstation. But here the aim is to not let any part go through the line if any error was detected. As you know, a part that will keep on going through the line with an error that will be detected at the very end of the line will cost a lot more to rework than if the error was spotted right there at the time when it happened. The fact that the production is also running smoother and leaner is going to help the operators be guided to achieve their work, so that by repeating constant operations, the production line will run better and your productivity will also increase. Here, there is an important aspect of optimization that we need to address. Optimizing does not always mean going faster. It means running smoother. So we talked about smart tools in general, and today we will have a closer look at the Mountz smart tools. And on the picture here, we can see the ECTD controller connected to its ECT driver. And these tools, of course, offer error-proofing systems, error-proofing features. These are also transistorized tools, meaning that they come with a built-in torque sensor, so that the torque is constantly being monitored and checked, so that we know in real time what is the torque being applied on the fasteners. We can use these tools to achieve multiple fastening tasks, and we can also program them to have and run through automation sequences. As these tools offer different fastening strategies, they can replace up to 15 different drivers into only one tool. So for you as a user, this means that you can reduce the space dedicated to the production or to the assembly of a specific part, bring all those workstations into one so that it liberates space for other jobs that you want to do on the work floor. These tools, as it is the case with some smart tools, can communicate with PLC on the line. So here, the aim is that the PLC and the smart tools, the ECT tools, will work hand in hand. And a very typical type of application would be that the PLC will command the tool on which fastening strategy to use, and the tool will then give the PLC a feedback on the fastening events, so that we can go give a feedback to the PLC that everything is okay, or something went wrong here. We need to stop and have a look at what happened. Another common device that is used with the tools are bit socket tray. So here we have a 4-bit tray. And as you can see, it consists basically of 4 holes with an LED for each hole. And these trays can be used in 2 different fashions. The first one as a master. And when used this way, it means that when the operator removes 1 bit from a specific hole, the socket tray will then tell to the tool which fastening strategy to use that is linked to this specific bit. The other way to use a bit tray is as a slave. And in this case, we will select the fastening strategy on the driver and then indicate through the LEDs which bit to take. And in the event that the operator removes the wrong bit, the tool will be locked, ensuring that only the right strategy is used with the right bit, and in the end, the right fastener. Another device used very commonly as well is barcode scanner. So here, the barcode scanner can be used for 2 different layers of information. The first one is simply to scan the barcode on the part and link this barcode to the fastening data. But the upper layer is to use those barcode information to actually select the fastening strategy to use, so that you can have different parts on the line, and depending on the barcode being scanned, select the right fastening strategy for the right part. Of course, in this case, the barcode value is still stored with the fastening data to go back to the traceability point we were talking about a bit earlier on. Proximity sensors are also generally used around assembly stations. So here, the aim is that we would detect if a part is present at a specific place, in a clamp as an example, so that the tool will be locked until the part is present, so that we can prevent any wrongdoing with the tool. This is a pick the light type of sensor. So here, what would happen is that the operator will come, pick the fastener. This sensor will detect the hand of the operator and will select the right fastening strategy depending on the screw that is being picked by the operator. And finally, we can also have in and out sensors on a moving production line, so on a conveyor. So here in this case, the tool would be locked until the in sensor detects the part sliding in front of it. And then we can ensure that the operator has to make their tasks before the part moves out of the area. And if they don't, we would have an error signal, meaning that something is wrong and the part needs to be looked after. When we talk about automation, this is what most people have in mind. This is a robot with a torque spindle on it. And as you can see on the left-hand side of the screen, we have a tray with different vacuum heads. So the tool will come, pick up a head, then go to the screw presenter, vacuum the screw. Then we have an imaging system that recognizes which hole needs to be done with which fastener. And as soon as the first fasteners are done, the tool will drop the first head, go and pick up the second head, and go on and on like this until the whole assembly process has been done. As we go through the video, you will see different type of purely and 100% automation applications. But of course, there are several layers in automation. These are, again, pure automation, but more and more automation is used as a support for the operators with collaborative robots, also called cobots, that will help the operator through their repetitive tasks so that the operators don't necessarily have to do them, or also to achieve critical applications or critical jobs where human error cannot be happening. Here, let's then jump to the demo portion of this webinar, and we will start with presentation of the tool that we will use for today. The first one is going to be the battery tool that you can see on the right-hand side of the screen. So the tools can work as standalone tools, communicate all the fastening data through Wi-Fi directly to your network, but we can also connect those tools to the controller, the screen that you see on the right, and this controller can manage up to 8 tools at the same time. So we will be taking a look at the controller screen so that we can see the actual data being pulled from the tool. Then we will move on with the ECT tools. And here what you can see is the tool being mounted on a torque reaction arm, but it is not a simple torque reaction arm. It is actually a positioning system that is communicating with the screen you see on the top left. And this positioning system is working with the ECT tools all together to really bring a full error-proof fastening system. So let's have a look at the battery tool first. So here, what we can see is typical fastening data. And on the left side, on the left column, we have the fastening date and time. Then we have the tool name, which is the serial number of the tool. If we had any barcode scanned, the barcode will be populated here for each line separately. Then we have our fastening time, our preset number, preset being the fastening strategy being used. We have our target torque, our converted torque, so the torque applied on the fastener. Here it's at 0 as I used an angle strategy. The fastening speed, the different angle, the screw counting here feature, and a very important one, of course, is this error column here. So here we are at 0, everything is happening well, but if we had an error, we would have the error code populated here, and then we could identify what went wrong during the assembly. So as I go on and on, you can see that the fastening values and the fastening data are being populated in real time. And this fastening data is also saved onto the SD card that is coming with the controller. It's a CSV format, so it's very easy to handle afterwards. And it's also sent, of course, through the RS-232 and Ethernet ports to the network so that you can also collect this fastening data in real time on your network. So this is the first layer of automation where we check what's happening on the tool. We can also give different access level to the operators depending on the freedom we want to give them. But these tools offer an additional layer of automation, which is the job function. So let me activate it here in the settings with job. So of course, the jobs can be selected with barcode or through the IO at the bottom of the controller. So here I will open this job. And what you can see now is that we are displaying a message to the operator. This can be to use a specific tool. This can be to put the part in a specific place. And then we have a picture of the actual part with the indication of where is the first fastening position so that the operator is guided to it. We make it fastening good. Second position shows up on the screen. We can enlarge or reduce the radius, change the color for visibility purposes as well. And as we did those two first fastenings correctly, we then display another message to the operator, which is this time to take the angle head type of tool. And of course, as you can imagine here, once we tell that to the operator, the pistol tool that was used for two first fastening is disabled, and only the right tool for the right fastening is unlocked and able to work. So again, as you can imagine here, the aim is to ensure that the right fastening strategy is being used for the right fastening, as we can also change this fastening strategy for each position. Fastening okay, we move on to the second fastening, job okay, and we look back to the beginning of the job, put a new part in, and we go on this way. So these are the two first layers of automation. Another layer that is offered with our Condy tools, so the ECT tools, is going to be models. So here we would have different several lines of commands to the tool, and the tool will have to go through each line one by one. And what we can see on the screen now is that we are using model 1, we are using step 1, which is a fastening step, with the preset 1, so fastening strategy number 1. I invite you to have a look at the torque value. So here is the target torque, 2 Newton meters. This is the screw counting features. So we need to make 3 fastenings in this first fastening step. And as you will see, we can then display the torque value reached, 2 Newton meters, target torque, 2.01 Newton meters, torque achieved, so torque applied on the screw. And now we have 2 screws remaining out of 3. So I'll go ahead and make another fastener. Fastening okay. Fastening okay. And then we switch to the step 2 of this model, which is going to use preset number 5 with a target torque of 5 Newton meters. And for this step, we have 2 screws to tighten. Fastening okay. 1 screw remaining. Fastening okay. Model complete. And we look back to the beginning of the job here, so that we can then again remove the part and put a new part in. So this is the third layer of automation, but there is a fourth one, which brings us to the combination of the positioning system with the ECT tools. So here I need to adapt and change the setting of the controller to allow it to work with the positioning system. back to the main screen. And if you keep looking at the controller on the right-hand side, you see that the tool is locked, meaning that I'm not in position, so I'm not on the position where the first fastening needs to be done, so the tool cannot start. I can press the trigger as much as I want, the tool is locked, it does not start. And I invite you also to look here to the fact that we are using preset 1, so with our target torque of 2 Newton meters. And then if we look on the left-hand side of the screen, we have the screw plate here that I'm using for this demonstration. And you can see number 1 in red. This indicates the first fastening position to which the operator needs to go to. And the fact that it's red means that the tool is locked. If we get closer to the position will light up orange. So we are getting closer, but the tool still does not start. So I have to be on the right position so that I can then start the tool. You see on the screen of the controller that it's now okay, ready to go. So let's go ahead and make a fastening. Fastening 1, okay. We then need to move to fastening position number 2. The tool is locked again, but we change the preset number. We are now using preset 3. So this can be a different target torque and a different fastener. Tool is okay, ready to go. Fastening okay. Position 3, okay. Fastening okay, and then position 4. We can go ahead. Job is complete, and we again look back to the beginning of the job. So here we used the positioning system in a sequence way. This is going to be relevant for different type of applications. As an example, for parts with gaskets or seals in between, where the seal need to be sat properly through different fastening cycles. But we can also disable this sequencing and allow the operator to do the fastener as they wish. But in this case, of course, each fastener can only be done once, so that we know in the end that when the job is complete, all the fasteners have been properly tightened, as the ECT tools control every aspect of the fastenings, but also that they are all done here through the positioning system that is monitoring the fastening positions and monitoring the count of the screws, so that it's 100% foolproof assembly station. And for you, what that means is that when the part leaves from this station, you know that it's been properly assembled. So this is basically the last layer of human working with automation. The upper layer will be with collaborative robots, and the last layer will be, in this case, the full automation process, for which we also have solutions that will be presented later on. So at this stage, we can move to the questions that you may have, and Tom will read them out loud, and I will be happy to answer those for you. Tom, do we have any questions?
Adrian, we have a couple of questions. The first one is, what is the maximum number of bits you can have on the socket tray?
Our socket trays are available with 4, 8, and 12 bits, so that the maximum is 12 bits.
Okay, and the next one is, can the ECT connect to my internal network?
Yes, it can. Both the corded tools and the battery tools can connect with your network through different communication processes. Both the controllers for the corded tools and the battery tools have RS-232 ports and have Ethernet ports. We can communicate in different communication protocols, but also the battery tool as a standalone tool can connect to your network over Wi-Fi so that you can collect the fastening data in real time directly from this tool.
And the next question is if my network goes down, is the data saved on the ECT?
Yes, it is. The ECT comes also with an SD card that will store every fastening data. So does the battery tool controller. And as it comes to the battery tools themselves, they will store up to 3,800 fastening data that you can then back up as soon as the tool connects back to the Wi-Fi and to your network.
Okay, and that's all the questions, Adrian.
Okay, great. Well, thank you very much, everyone, for joining us this morning or this afternoon for some of you. It's always a pleasure to have you here, and we will be looking forward to see you next time. Have a nice day, everyone. Bye-bye.